Take a look at this pancake-shaped stack of clouds hanging out off to the east of Mount Shasta this morning, as captured by the Alert California Girard Ridge camera. It's really cool, and it looks like a lenticular cloud. And it is. But why is it not sitting over top of the mountain? Well, we'll talk a little bit about that, but first we have to talk about how we get these lenticular clouds in the first place. That's our first clue. The key thing that you need is a stable atmosphere, basically air staying put where it is. Even if you push it in either direction, whether you try to lift it up or push it down, it wants to go back to where it started. A great example of this is think about taking a cereal bowl and putting a ping pong ball in the bottom. If you by hand try to force it up the slopes of the wall of the bowl, and then let go, it's not going to stay on the wall of the bowl. It's going to go right back down to the bottom. And so that's a stable environment, right? You can make all these changes, but it's going to go back to where it started. The atmosphere does the same thing. Think about an unstable environment. That's the opposite. You take that cereal bowl and literally flip it upside down, and then you put that ball on top of that upside down bowl. You push it in any direction, it's going to go rolling, and it's going to continue to move. And that's what's going to happen when we have an unstable environment, like we will over the weekend. What happens is we get a little bit of lift, and that air is going to continue to rise. We get towering clouds, and then we get thunderstorms. But we have a stable environment in place here on Friday, right? Things stay where they are, even if you try to push them. If we try to push that air up, it's going to be colder than the air around it, so it's going to sink back down. If we push that air down, it's going to be warmer than the air around it. It's going to rise back up, so it wants to stay right where it is. We have that in place. We've got the stable atmosphere. The other key thing is we need some moisture, right? You can't form clouds without some water. So we have that. You can see that cloud deck kind of hanging out there around the snow line on Mount Shasta. So we have some moisture, we have stability, and then we introduce the wind, right? That wind is going to create that flow. And so what happens is we have winds coming out of the west, riding towards Mount Shasta, right? Shastina's hiding behind the clouds there, and it's going to ride up to Mount Shasta, and then it's going to run into it, right? That air wants to stay level where it is, but it's forced up the landscape. So we get this lifting, and again, this is a stable environment, so that air that's going up doesn't want to and cannot stay up. It's going to come back down. So it's going to ride down the slope of the mountain, right? It rides up, and then immediately is going to drop back down. But think about pushing a kickball underwater, right? Anything with some buoyancy is going to roll out of the water and bounce right back up. And so that's what's happening is we push it down, but again, it doesn't want to be down that low. So it's going to kind of overcorrect and bounce back up above its normal level. And then we condense out those clouds, right? The air can no longer support the moisture. So that water vapor turns into liquid water into clouds, and we get that kind of shell shape out there as those clouds kind of bounce up. And then that air comes right back down. And we see maybe potentially a continuing train of that. But in this case, that was all she wrote. After that, air smoothed out and leveled back off to where it wanted to be. So that's the story of lenticular clouds. And again, that west wind really allowed those to form off to the east of the mountain because we got that downstream effect. That's my little explainer for the day. I hope you have a fantastic weekend. I will be keeping my eye out for more lenticular clouds. But first, that unstable scenario will be out there this weekend, giving way to maybe a lot more of those puffy cumulus clouds that we like to see in the spring.